both equations are already solved for y. So all we have to do is just put them together. We'll put this y in place of that one. So negative 3/4 x plus 5 equals negative 1/4 x plus 1. Now remember, we have our steps. We have to combine what we can on either side. There's nothing to combine on either side here. We have to get the variable to one side. Well, there's x on both sides here, so I'm going to have to get rid of 1. Negative 3/4 is actually the smaller one, so I'm going to add 3/4 x. Making sure I add it to the other side as well. So I have 5 there equals negative 3/4 or negative 1/4 plus 3/4. Negative 1 plus 3 is 2, so that's 2/4 or 1/2 x. And then plus 1. Now we're ready to start to solve. We'll subtract 1. 5 minus 1 is 4 equals 1/2 x. And we'll divide by 1/2. Or you could multiply by 2. Either way works. 4 divided by 1/2 is 8. 8 equals x. So we know x equals 8. We have to find y. We have to go back to either one of these equations. I'm just going to pick the bottom one. Doesn't really matter. And put 8 in for x. So y equals negative 1/4 times x becomes times 8 plus 1. Negative 1/4 times 8 is negative 2. Well, y equals negative 2 plus 1 is a negative 1. So y equals negative 1. So the solution to this system is x equals 8 when y equals negative 1. Now, like we did yesterday, we could go back and put negative 1 in for y, 8 in for x, and verify that we get the same value on both sides. Negative 3/4 times 8 is negative 6. Negative 6 plus 5 is negative 1. We get negative 1 on both sides there. Put negative 1 in for y, 8 in for x. Negative 1/4 times 8 is negative 2, plus 1 is negative 1. So we get negative 1 on both sides again. The second system is a little trickier to do. Remember, we said our first step is you have to pick a variable in one equation and solve for it. In this one, there's one that we definitely want to avoid, and that's right here. We don't want to solve for x in that first equation, because solving for x in that first equation, at some point we have to divide by 3 to get x alone, and dividing by 3 gives us repeating decimals, which we can't have. A repeating decimal is going to require us to round off, so it's going to make our answer be slightly off. So we would have to work with the fractions there. We would have to work with 1/3, 2/3, whatever fractions we came up with. For ease of reference, I'm going to label these equations A and B. I could solve for y in equation A, dividing by 2. The worst it's going to do is give me a decimal 0.5. Same for solving for x in equation B. But I see that the y in equation B has no coefficient. It's a 1y or just y. So if I solve for that one, I don't have to divide by anything, so I'm not going to get any fractions or decimals at all. So let's do it. So we're going to solve this equation for y. Means we're going to subtract the 2x. So we have y equals 1 minus 2x. That's it. We're done. We've solved that for y. Well, we're not done. We now have to go back and put that into the other equation. That's equation B that we just solved. We have to now put it into equation A in place of the y. So we have 3x plus 2. Instead of y, I'm going to put in 1 minus 2x and equals 4. Now, remember, we combine what we can on either side. On the left side, we start off, we've got parentheses first of all, nothing to do inside there. So we're going to multiply by the 2. So first we'll bring down the 3x. 2 times 1 is a positive 2. 2 times negative 2x is a negative 4x. Equals 4. Next, we'll combine what we can keep combining over here. 3x and negative 4x is a negative x, or negative 1x. Still have the plus 2, equals 4. We'll subtract 2 from both sides. Now we can start to solve. Subtract 2 from both sides. We have negative 1x equals 2. And we divide by negative 1. X equals negative 2. We still have to find y, but luckily, so y equals 5. So our solution to that equation is x equals negative 2, y equals 5. Well, substitution is kind of a long process. And it requires solving for that one variable. Here we got lucky. We had that y with no coefficient, or a coefficient of 1, however you want to look at it. So that when we solve for it, we didn't have to divide, so we didn't end up with any fractions or decimals. But often we are going to end up with some form of a fraction or decimal that we have to work with in substitution. So there is a third method. We've got graphing, we have substitution so far. There's a third method, depending on the textbook. It's sometimes called the elimination method. Or our textbook actually calls it the addition method. They mean the same thing. We are trying to find variables that will cancel out. We can eliminate them by adding them together. So let's take a peek here at a system like 3x minus 2y equals 11, and x plus 2y, oops, this should be 11, equals 1. So, looking at this, remember when we solve equations, if I have an equation like 3x minus 2y equals 11, I can do the same thing to both sides, and it won't change. Remember, it's a balanced scale. It won't change how that scale balances. It won't change the equality. If I add 1 to both sides, if I add 1 over here and I add 1 over here, it's not going to change that equation. So that's what I'm actually going to do here. I'm going to add 1 to both sides. Only I'm not going to do it in the same form. I'm going to add 1 over here on this side. But on this side, this second equation tells me that 1 equals x plus 2y. So adding x plus 2y is the same as adding 1 because they're equal. So I'm adding, I'll take the plus sign out of there. On the left side here, I've got 3x plus 1x is 4x. Here's the key right here. I have a negative 2y and a positive 2y. That's 0. Negative 2 and positive 2 add to 0. So the y's cancel out. Equals 11 plus 1 is 12. So just like with substitution, we reduced it to one equation and one variable. We've done the same thing here with our addition. Now, some keys here that I'm going to point out before I continue with that problem. It has to be lined up, the x's, the y's, equal signs, and then we refer to these as the constants. Those are the constants. There's no variable in those. They have to be lined up like that. X's, y's, equals, constants. So that's the first thing that has to happen. The second thing that has to happen is you'll notice we had a negative 2y and a positive 2y. You have to have a variable that's going to cancel out when we add them together. Because once we've got them lined up here, all we're going to do, like we did over here, is just add down the columns. The 3x plus x gave us the 4x. The negative 2y and positive 2y canceled out, and the 11 and the 1 gave us the 12. So once we've done that addition and one of the variables has been eliminated, has been canceled out, we have one equation with one variable. We can solve for that variable. We'll solve for x by dividing by 4. X equals 3. The addition method or elimination method, whichever name you want to use, is generally quicker to get to that first variable. Substitution, we had a lot more work to do to get to that first variable. We pay for it on the other end, though. We still have to find the second variable, which means we have to put this 3 back into one of the original equations to see what we get for y. I'm going to use that second equation just because it's right there. So for x, I'm going to put in the 3 plus 2y equals 1. Now I have to solve that equation for y. I will subtract 3. 2y equals 1 minus 3 is a negative 2. Then we'll divide by 2. Y equals negative 1. So this gives us the ordered pair x equals 3 when y equals negative 1 as the solution to that system of equations. We have to be able to pick and choose. When I look at a system like this, my first instinct is going to be nothing lines up, nothing cancels out. I would be tempted to use substitution on this. Let's solve it with substitution. I'm going to label them equations A and B. And it looks like the easiest one to solve for here is going to be the y variable in equation A. So let's solve for y up there. 3x plus 2y equals 4. I'm going to subtract 3x to get 2y equals 4 minus 3x. Then I'm going to divide by the 2. Y equals 2 minus 3 halves x. That's that equation A now that's been solved for y. Let's plug that into the other equation. So 6x plus 4, instead of y, I'm going to put in the 2 minus 3 halves x equals 8. So now I'm down to one variable with one equation. I can try to solve that. I'm going to multiply the 4 through my parentheses. So I'll bring down the 6x. 4 times 2 is a positive 8. 4 times negative 3 halves x is a negative 6x equals 8. Now we have to keep combining on the left side. 6x and negative 6x adds up to 0x, or just 0. So we get 8 equals 8. the variable disappears. When that happens, there's two possibilities. We have to ask, is this true? And it is. 8 does equal 8, doesn't it? If 8 equals 8, if the two numbers are equal, or what we get there is two things that are equal, a true statement, a true equation. If that's the case, then our solution, what that means is that these two equations, if we were going to graph them, let's see, we'd have like 2 and 1.5. These two equations are actually the same line on the graph. So that's telling us there's an infinite number of solutions. But more specifically, the solutions are just one of the equations are the same. Any solution to one equation is a solution to the other equation. So my solution, I can just write down running the equations. Any solution to this equation will be a solution to the other one. Now, a similar thing that we can run into would look like this. So you have 2x minus 3y equals 6, and 4x minus 6y equals 8. Here our only, well, we could solve for x in either equation. Dividing by 4 isn't bad either. But we're going to solve this top equation for x. So 2x minus 3y equals 6. We're going to add 3y to both sides. 2x equals 6 plus 3y. Then we'll divide by 2. X equals 3 plus 3 halves y. So we have solved equation A for x. Let's substitute it back into equation B here. 4 times x becomes 4 times 3 plus 3 halves y minus 6y equals 8. Now we're down to one equation with one variable. So let's combine what we can on the left side. 4 times 3 is 12. 4 times 3 halves is 6y. And we have a negative 6y. So once again, we'll combine 6y and negative 6y. Once again, disappears. 6y plus negative 6y is 0y, or just 0. So we have 12 equals 8. This is not true. What that means, when we get something like that, two numbers that are not the same equal to each other, it's not true. That means these are parallel lines. Which means they never intersect, and there is no solution to that system of equations. These two lines on the graph, let's see, we have what, negative 2, would look something like this. So they never intersect on the graph. They're parallel lines. So there can't be a solution for those. So we have to be careful. There are some strange things that can happen that can keep us from getting a solution to our system, and it's valid. Just because the variable disappears does not necessarily mean you did something wrong. So let's go back to that addition method again. We might have 4x minus 3y equals 15. And we might have negative 4x plus 3y equals a negative 15. Well, here, first thing we got to make sure is they're lined up. They're lined up x's, y's, equal signs, and the constants. It's lined up. So let's go ahead and add our columns. Just add it up and see if anything disappears. And it starts out looking pretty promising. 4x plus negative 4x is 0x. That disappears. However, we get to the y's, negative 3y and positive 3y, adds up to 0y. The y disappears also. That means on the left side, what we have is 0. On the right side, 15 plus negative 15 is also 0. This works exactly the same as it did with our substitution examples we just did. This is true. 0 does equal 0, which means those two equations are the same line. So our solution, there's infinitely many solutions. Our solution is just to write down one of the equations. 4x minus 3y equals 15. Any solution to that equation is a solution to the other equation because they're the same line. Well, let's look at one that isn't trivial, that doesn't all cancel out like that. So let's do 2x plus 4y equals 2. Negative 2x minus y equals 4. Once again, I'll label them equations A and B just to refer to them simply. Now again, if we're going to do that addition or elimination method, the first step is to make sure things are lined up. We have x's, we have y's, we have the equal signs, we have the constants. This is lined up, it's going to work. So let's add the columns and see if anything disappears. And it does right away here. We have 2x and negative 2x. That adds up to 0x, or cancels out. Next, we have 4y and negative y. We treat that as a negative 1y. 4 and negative 1 make 3y. So we have 3y there. Equals, and then on the other side, 2 plus 4 equals 6. So now we can solve for y. We're just going to divide by 3 to get y equals 2. Now we can go back and we can use either of the original equations to solve for x. We put the 2 in for y. I'm going to use the top one because there's no negatives. I prefer to work with positive values. So 2x plus 4y, well, 4y becomes 4 times 2 equals 2. I have to combine what I can combine first. 4 times 2 is 8. So that's 2x plus 8 equals 2. And now it's just an equation to solve. I'll subtract 8. 2x equals 2 minus 8 is a negative 6. And I divide by 2. X equals negative 3. So our solution is x is negative 3 when y is 2 is the solution to that system of equations. Now, I prefer the addition or elimination method, even though it's a little more work to find the second variable, a lot less work to find the first one, in my opinion. There are going to be systems of equations that are set up to be easier to solve with substitution, just because of the way the variables are, the equations are set. Not all of our equations, not all of our systems work quite as easy with that addition method as these last couple of examples have. We can run into something like this. 2x minus 5y equals negative 5. Or 3y equals 2x plus minus 1. So I'm going to label these equation A and equation B again, just for ease of reference. Equation A is fine. X, y equals constant. Equation B, not so fine. It's in the wrong order. I need to get this x over to the other side. So to do that, I'm going to start by subtracting 2x. Now, 3y minus 2x, I could write it as 3y minus 2x. Or I'm going to do this, I'm going to write it as a negative 2x plus 3y. Because I want them in that order, x and then y, then the equal sign. On the right side, the 2x and negative 2x cancel out, I have negative 1. So my system of equations becomes, the first equation hasn't changed. 2x minus 5y equals negative 5. But equation B now is negative 2x plus 3y equals negative 1. Now everything is lined up. X's, oops, get out of there. X's, Y's, equal signs, and then the constant. So we can go ahead and add our columns and see if something disappears. And it does. 2x and negative 2x add up to 0. They cancel out. Negative 5y and a positive 3y is a negative 2y. Negative 5 and negative 1 make a negative 6. Once again, we're down to one variable in one equation. We can solve for y. We'll divide by that negative 2. Negative 2 is gone. Y equals negative 6 divided by negative 2. Negative divided by negative is a positive. Positive 3. Y equals positive 3. Now to find x, I can go back to one of the original equations, or I can go back to the one that I solved for. In this case, I'm going to go back to this original one, the bottom one, because that already has x and y on opposite sides of the equation. So I'm going to put in there 3y becomes 3 times 3 equals 2x minus 1. Well, I'll combine 3 times 3 is 9 equals 2x minus 1. I'll add 1 to both sides, giving me 10 equals 2x. Then we'll divide by 2. 5 equals x. So our solution here, x equals 5 when y equals 3. We will do more of these tomorrow. We'll look at, obviously they're not always going to stay that simple where something's already set up to disappear when we add them. For now, we'll get you started on homework. This is in the big book. Page 479 through 480. This is exercise 17-3A. We do problems 7 through 23, the odd. So we have about 15 minutes left if you'd like to get started on that. I'll stay on the network here to answer any questions. Otherwise, that is